Good evening, everyone. Today's session is on queues that we use in our data structures. Right, so queues basically talks about how to store the data and how we are going to store it, what is the format, and how we can access the queue, how we can create queues using arrays or using linked list. So we will be having a complete introduction first of all, and then we are moving into the implementation part of queues. So queues in computer science, what it's telling you, it is basically like in operating system, how we use the queues of print jobs to send to the printer. We make a queue. Everyone has seen this part, like when you send the document to the printer, right? And if you are sending more than two documents, it is maintaining a queue, and you can easily identify like this is my first job, this is my second job, this is my second job, and it is maintaining in a printer queue, right? Queue of programs and processes to be run. So again, this is one of the application of queue of network data packets to send. So you have packets when you are sending any message, so it may be consisting of queues only, like you are sending in the form of queues. So in programming, modeling a line of customers or clients, right? So storing a queue of computations to be performed in order. So this is one of the application. And real world examples, people on an escalator or waiting in a line, right? You are maintaining a queue. Carts at a gas station, right? You have seen like a number of cars are standing for getting a gas, or you may say fuel. So let us see some of the operations that we can perform using queues. We can perform on queues basically. So add value, places given value at back of the queue. So whenever you are putting some values, you are putting from the back side. Like in stacks, you are putting from the top of the queue, top of the stack. But in queue, there are two things. You have the front part, you have the rear part. In rear part, you are inserting the elements. Removing the elements. So the first element is to be removed first, right? From the front of the queue. So remove the value from the front of queue and return it. Throw no such element exception, that in case of like whenever we have exception and when we don't have, if the queue is empty and you are removing something, so how it is going to be removed, right? So it is going to give you the error. Exception means an error. Peak means returns front value from the queue without removing it. Returns null if the queue is empty, right? Again, if you are peeking something, and you are finding out like without removing it, so it is going to give you the empty part, right? Then size, how many elements, what are the number of elements that are there in your queue. You may be using a function that is size. Is empty, again it is going to check out whether your queue is empty or not. So it returns true if your queue has no elements, right? So these are some basic operations, some basic methods that we used in a queue. Let us understand how we create it and how we perform the different functions. So we have created a queue that is of integer type, and we are inserting the values in the queue, right? That is 42, then -3, then 19. So this is our front of the queue. Let me tell you, I will be showing in other examples also. So this is the front and this is the back part. So whatever we are inserting from here. Whatever we are deleting from here. So it's a kind of a bus. Like you have seen the bus architecture, the people are get into the bus from here, and the people come out of this bus from here. So this is works like this only. The the basic logic behind that is using this. So note, when constructing a queue, you must use a new linked list object instead of new queue object. So you are creating a new linked list object. You are not creating a queue type of object, right? This is the actual working, like you are creating a linked list type of object, not the queue object. So let us see uh, how it works and what are the basic architecture of it. A queue is like a line of people waiting for a bank teller, or you may say it is going to have a queue in a bank. Like in earlier days also, we have seen, like, we used to deposit the cash in the banks, we need to stand in a queue. Nowadays there are a number of machines through which you can deposit the cash as well as to withdraw the cash, right? So let us see the example. The queue has a front and a rear. So here we have front, and here if we are talking about, it is like this. A queue is maintained in this sequence. If we are talking, this is a front, and if we have another, like this is the rear part, and this is the front part of the queue. So basically when we are talking about the front part, this is the front part and this is the rear part. So let us see what how we perform the queue operations. We perform how we insert the elements in the queue and how we delete the elements from the queue, right? New people must enter the queue at the rear. So whenever we want to insert into the queue any item, that is from the rear part. Rear part means from the end of the queue, from the back of the queue, you may say, or from the end of the queue, right? So I'm writing back or end. And if we want to get out, like I want some people to get deleted from the queue, so it is from the front of the queue. It's as like your bus, I told you. If it is a bus kind of architecture, it would be like this, right? People are getting from the at the back, and people are getting out from this bus from the front of the front gate. So this is like that only. The C++ queue class calls, this is a push. You may say you are pushing an element into the queue, or although it is also called enqueue when you are inserting something into the queue, when you are inserting elements, and it is inserted from the rear part, from the end of the queue. Let's see how we remove the elements, how we pop the elements. Uh, how we push the elements. Push using rear part. Now if we are popping the if we want to pop any element, we will be using the dq. So when an element is taken from the queue, it always comes from the front. So you are taking out from this part, right, from the front part. And the C++ queue calls this function as pop, although it is usually called as a dequeue function. Dequeue means you are deleting an item from the queue. You are deleting an item from the queue. So let's see what are the different functions we have in our queue class whenever we are using C++ library. So first of all, you have taken a template class, template library that has a queue template, right? And in this we have taken a queue class, which is basically having data members and member functions. So the first member function is queue itself. It is a constructor, and then we have taken for two things, for inserting an element and for deleting an element. So this would be our inserting, and this would be pop elements from the queue. Then we have if the element, if there is no element, and item is at the front part. So these are the basic functions we have in our queue. The template parameter is a type of the items that can be put in the queue, right? So we are making it as template. We can make it as a class also. Let us see the array implementation of queue, how we can implement the queue using arrays, right? A queue can be implemented with an array as shown here. For example, this queue contains integer 4, at the front 8, and then 6. So here is the indexing part also. This is the first element that was inserted, this is the second element in the queue, this is the third, and so on. Whatever elements you want to insert it, you may insert it, right? An array of integer to implement a queue of integers. We don't care what is in this part of the array. So basically we have initialized, this is the main disadvantage of array. Even we have initialized the array with some size or with some length. These parts are basically not holding any values. In fact, in our scenario, but it is initialized with like number of elements are there in the array. So let's see how we have the first part and how we check out the array implementation. The easiest implementation and also keeps the track of number of elements in the queue and the index of the first element at the first, that is front of the array, and the last element obviously it is at the rear part. So whenever you want to insert any element, you may be inserting from this part. If you want to delete an element, you may be deleting from. So this is our first element, this is our second, this is our third element, this is fourth, and so on, like this, right? So here we have the three things. You have size first and last. Let us see how it works. The size would be your 3, the first element is 0, and the last element is at 2. So there this is the index basically, or tells you about what is the size of an array. That would be 3 because it is storing only 3 elements. What is the first first index? That is 0. What is the last index? That would be 2 because we have only this number of this value, right? Now if I want to perform the DQ operation, now DQ operation means you have pop some element from the queue. So I told you the pop should be taking place from here and insertion would be taking place from here, from the rear part. So when an element leaves the queue, the size decremented and the first changes to, right? So now your size would be 2 because earlier it was 3, right? We have 3 elements. If we DQ, or if we pop one element, the size would remain what? 2. And then same as for the first element would be your now a1, or if your array name is a1, then it would be a1, and the second element, or you may say the last element, would be 2. So earlier it was 0 and 2. Why? Because we have 3 elements. If we dq if we perform dq operation, we need to change the counters also. After this we have nq part. If we want to insert an element into the queue, we might be inserting, it is possible, it is only possible from the rear part of the queue, and we are inserting the elements from at the back of the queue. So when an element enters the queue, the size incremented and the last changes too. So you don't have anything in this index because you have dq. You have performed the pop operation. Now here is 8 and 6. Now you have inserted the value, that is 2. Right, now your first is element. The size of the queue is 3. 1, 2, 3 elements. The first element is at 1 and the last element is at 3. So this is how we can use the, like how we maintain the pointers in a queue, right? So we are maintaining like this. Now if we have tq, we have nq. At the end of the array we have this thing, like if we are inserting something, if we want to dq and nq performing like this process ends like this. This is a special behavior at the end of the array. For example, suppose we want to add a new element to this queue. The last index would be 5, right? And your first index would be 3. Why? Because we don't have any element in this particular part. So these indexes are not used. We are going to use from A3 is the first element, A5 is the last element. And what is the size of array? There are 3 elements, so the size would be 3, right? So the size would be 3 and the last index of the array would be A5. Uh, right? If we want to like insert the new elements goes at the front of the array if that spot is not already used. So if, like we have seen, we have reaches to 1, right? Now nothing is there in the array. Now we want to insert any element in this list where it is inserted. So now it is inserted from the fourth part, right? So now your last element would be in, yes, would be in A0 index, because now you have inserted, there was no place in the previous array, we have used all the spaces, right? This is our like ending part of the queue. Now how to insert the value? We will be inserting from this side. A0, what is the size? 4. The first index would be A3, right? And the last index would be A0. So this is how it works. how we basically use array implementation in queue. Okay, let's see what are the different things, what are the different characteristics of this, what is the disadvantage and what is the advantage. Easy to implement, yeah, we have seen very very easy to implement. It has a limited capacity within a fixed array, so you have to fix the space. Even if it is not used, you need to fix it, right? Or you must use a dynamic array for an unbounded capacity. You may say the size of an array you have not defined, you just defining it by changing the global variable, or you are changing the size. Special behaviors is needed when the array reaches the end of the array, like this would be your different scenario when you have used all the indices, when you have used all the space. Now the in the deleted items where you have popped those items from the start of the array or the queue, you might be using inserting the value from that particular index. So this would be the reason for that. So let us see now. In this array we have 0 1 2 3 elements. The size would be your 3. The first index would be 0 and last index would be 2, right? Now let us move to a next implementation. This was the last was the array implementation. Now let us see the linked list implementation. A queue can also be implemented with a linked list with a both head and a tail pointer. So you need to maintain two things, head pointer and tail pointer. Why we are maintaining it? Because we have two parts in our queue, the front part and the rear part. So here comes the your head part. Head pointer is pointing to the first element, and then this element is connected to second element, this second element is connected to third, and third element is connected to the last element. Why it is called last element? Because we have null in the address bar. So node is maintaining two parts, right? The value part, this is telling the value, what is the value of your node, right? And the second is the address of the next element in the linked list. So here we have the address part. This is basically address of the next element in the list is stored here, right? And we know that when we have already studied about linked list, the linked list tells you about like the last element would be holding a null value that tells you that your this would be your last element. So this is how we are maintaining through linked list, right? Which end do you think is front of the queue? Now you need to tell me like from where you are inserting the elements, from where you are inserting the elements and from where you are pop the elements. So here becomes the scenario. The head pointers points the front point. That's what I told you. Okay, this is the front part, the starting part, right? From where the first element is there, and the last part is the rear part. Now you can point out the where the tail pointer is there, because hmm, it is harder to remove items from the tail of the list. So we need to remove the uh, elements, so we will be using some of them, right? So let us see how we have what we have understood from this session. Like stack queues has many applications. I have told you, like you are standing in a bank and making a queue, so you might be using like this. People are standing in a queue, and like I have shown you, this is a queue, right? And this is a queue in a bank, or you may say in a bus. People are coming in into the bus using in the from the rear end. Rear means at the back, and people are coming out when they, or you may say if they want to have in a bank also, if their number is coming, they, this is the bank, if their number is coming, they might be collecting the cash and going. So it is like it is one of the application where queues are used. So queues basically in data structures we have number of implementation we can implement through arrays that I have shown you. We can implement through linked list also, right? But the only advantage you may say of queue is using linked list. Why? Because it does not waste the memory part. So wastage of memory is like we don't have in the linked list type of scenario, right? Now let us see the, yeah, items enter a queue at the rear, right, and leave a queue at the front. So basically the member which is inserted from the first, right. Let me give you one example also, because it is very very important to have the structure. Suppose I am saying this is my front and this is my rear in the queue. I have entered the elements, right? So there are number of elements that I have entered: 1, 2, and 3, and so on, right? So there are number of elements which are there in the queue. Have you observed which type of sequence it is maintaining? The element which is first inserted is coming out first. It follows FIFO order. First in, first out. Yes. So it is very very important when we talk in terms of stacks and queues. Stacks follows LIFO order, last in, first out. It works like that because in a stack you might have seen in my previous session, you might be having such kind of stack, right? 1, then 2, then 3, and so on. So this is my top pointer is like it is having some value. So now the last element should be come out first. It follows LIFO. LIFO means last in, first out, right? Whereas in queues we follow the FIFO order. The element which is first inserted will be coming out first. So it follows FIFO order, first in, first out. Right? So it is very, very necessary to know and get the difference between stacks and queues. So these are queues and these are stacks. So stacks follows basically LIFO order, last in, first out, because the top of the pointer, the top of the stack is pointer is denoting. And why it is denoting? Because if we want to delete any element, we will be deleting the last element from the stack. In case of this queues, we will be inserting the elements from the rear part and deleting the elements from the front part, right? So the element which is first inserted will get first out also, right? The first in, first out. Queues can be implemented using arrays and a linked list, same as for your stacks also. Stacks can also be implemented using array or a linked list, right? Hope you have understood the session. Hope you like the session and understand what are the different applications of queues and how you are going to use these queues, right? So this is very very important when we are talking in terms of memory, right? If we want to save the memory, we will be using the linked list. And like if we, yes, arrays are faster, and arrays you can basically randomly access the indexes of the array elements, while it is difficult to access the uh, elements of linked list randomly, right? So in both the cases this would be the difference, right? So hope you have understood the linked list and the array implementation of queues, and the very important part, that is what are the uh, applications of queues, right? What are the applications of queues where we actually use these queues. So it is used, it is widely used, and in like in a printer, in a like in a bank also we are using the queues. There is like in sending the packets also we are sending, like suppose I have sent one message, right, and again I have received some of the content, some of the content get like it, if it is not synchronized, it is going to not received by the as a, like receiver. So for maintaining all these things, we need queues for having some numbers, for having a track of all the packets, right, and even for synchronization purpose also, right. In you may say in programming we are using through a line of customers, maintaining the line of customers, and then it is going to provide you the results, right. Or in real world we have seen, we have taken the example of like we are standing in a queue for metro line, and to enter into the metro, right, metro coaches. So we might be standing in a queue. So these are the real time examples where we are maintaining the queue. And here we have understood how we maintain the queue, how we have a list of items in a queue, how we stand in a queue, how we implement using arrays and linked list, right. So hope you have understood the session, hope you like the session, and I will be coming with more examples, right. Thank you.